So I'm Julian Clark. I'm work in IT, so this won't be a professional broadcast. Please bear with me as I wander around my house with a. I'm going to switch over to my iPhone shortly. So as Rebecca said, I live in a bungalow. We're in rural Worcestershire. We bought it in 2021. Sorry, we didn't. We bought it in 2001, and it was a new build then. So it came with double glazing. It has a part-filled cavity wall. It had 150mm loft insulation, and at the time it was heated by oil. We used to use something like 5,500 kilowatt hours a year of electric. With judicious training, we got that down to about 4,000. And I'll then talk about what other changes we've done since then. Now, I'm coming at this from a retrofit point of view, but I'll try and explain that I think the principles we're talking about here will be the same from new builds. It's just you know, there's certain tweaks, etc. Now, the big thing we're going to talk about is the air source heat pump. But I'll come on and go through, you know, a little bit more about that. But it's the important thing to mention is, I think it's probably the fourth most expensive thing that you have in your that you spend after your house, your car, the kitchen you might have, and then the heating system. So the heating system is a complex beast, and traditionally, you know, with all due respect to plumbers, throwing up an oil or a gas boiler on the wall of your property and over specifying it was quite easy. I couldn't do it myself, but for plumbers it is easy. But an air source heat pump is a lot more complicated than that. It has to be specifically designed for the property, be it a new build or be it a retrofit in my case. So you have to employ a heating engineer who can design the system for your home. So it's not just a case of your friend down the pub who's a plumber can have it fitted. Right, so I'm going to go for a wander around the house now. I'm going to switch over from my laptop, which I'm speaking to you now, and hopefully there'll be a smooth transition to my mobile phone. One moment.
That worked well, Julian. You're just on mute, though. You are on mute. Oh, I spoke too soon. Oh, he's back. Hang on. Still on mute. I don't think you unmuted that. There we go. There we are.
There we are. Yes, I was being careful. I'm getting. So I'm going to wander out the front door first of all.
We can only see a slither of you in the screen. Is that? Are you on? That's better. Perfect. Perfect.
So I'm now outside. Let me just. Now, how do I switch my camera to the front camera? Oh no, that's me.
Yeah. Reverse it around.
There we go.
Turn it around.
Right. So the first message I want to say. Can you hear me? Okay.
Yes, we can.
So the first message I want to say is invest in solar. Whether you're a retrofit or a new build, this has been the best investment we've ever made. We've had the solar since 2012, that February. We have you see 16 panels on 2 strings, and that's 4 kilowatts. We generate about 3,700 kilowatt hours a year. We're lucky in the fact that this roof here is south facing, so we get maximum benefit. But the only reason you wouldn't have solar, I would say, is if you've only got north facing roofs, which is almost impossible. You can still get very good solution from east west facing. Even, you know, grade 1 star listed buildings can have solar fitted. National Trust has it fitted. Churches have it fitted. So I think there's very little excuse why you wouldn't have solar fitted. And it really does have a big impact on your savings, etc. Right, let me wander around next to the let's talk about the
Oh, I think we might have lost him. Yeah, out of day. Oh,
am I back on camera again?
you're back on. Yeah, we did
Okay.
temporarily lose you there. Yeah.
Yes, it was switching over between the Wi-Fi services. So the next thing to think about, and here's my oh, their spiders are back again, sorry. So this is my electric cupboard, and the thing to think about here is the 100 amp circuit. So here you can see my 100 amp circuit coming in. Now I think you'll need to have a 100 amp circuit. You have to get permission to apply an air source heat pump or a or even solar actually, or electric vehicle charging point to your local DNO, that's district network operator. In our case, it was we're with Western Power. But you'll need a 100 amp circuit coming into the house. Older properties will only have 60 amp circuits, but I believe it's a free upgrade you can request from your DNO to make sure that happens. So you've got sufficient power to your home, and even older properties might even have shared lines into between, like party lines that you used to have for telephone. You get party lines for power circuits as well. So again, that's something to consider and get upgraded. You'd also
Julian,
see,
did you have to pay for that to get the upgrade, or did they do that for free?
so my home came with it. Because it's a relatively new house. It was I already had the 100 amp circuit, but I don't believe you have to pay for that. No.
You do if you're upgrading to 3-phase usually. So you have to get a budget from the DNO. So it's worth just checking out really and asking the question. So
I don't think 3-phase is necessary.
Right.
For the majority of homeowners, unless you've got a workshop or something like that, you want 100 amp will be able to. So we're a fully electric house now, 2 electric cars, solar running on 100 amps. And we have quite a large air source heat pump, which I'll show you in a moment. So I don't think you need 3-phase, but potentially.
Depends the type of property, I guess, because
yes.
Depends how big the property is.
The only other thing I wanted to point out was this 2, they're called electric clamps. One of them is for my Tholic, and I'll talk a little bit about that. And the second one is for my Zappi, which is my EV charger. So shut that a second, and we'll now wander. So this is my external unit of my air source heat pump. We used to have an oil boiler here. This is you see the concrete pad that used to have a 2,500 litre double skin, so bunded oil tank sat there. But when we had the air source heat pump fitted, we no longer needed the oil boiler. Now I originally got involved through, I think it was E.ON, who got in touch. I saw an advert, and they were doing what was called a bivalent system, meaning that you would keep the oil boiler and they would put in a smaller air source heat pump, and they came and did the calculations. This was just over 2 years ago, and it seemed to me to add complexity. I've therefore got 2 systems to maintain, two servicings, 2 things to go wrong. They reckon that 80% of the heating would be via the air source heat pump, and only when it got really cold would the oil boiler kick in. So, but they wouldn't entertain a bigger air source heat pump. So I then started researching, and there's a separate video about that, I think, through Mesh. Things to consider when you're locating. So this is quite a large unit. It has to, in order to meet planning regulations, it has to be under 0.6 meters cubed of volume, and it has to be more than a meter away from your neighbour. This unit from Daikin is a very quiet unit. It's actually 12 kilowatts. It's quite a large unit with a 6 kilowatt backup that we've never used. But you see, it's actually quite close to the power. Like the power, the meter cupboard I just showed you. That's important. So you haven't got too far to travel.
Julian, is
sorry.
it on? Is it on right now or not? Because can we hear
No,
it?
it's not. No,
Is
it's
it
not on.
quiet? Yeah.
It's not on. Sorry, it is switched off. But when it's running, there's actually a quiet mode that's 35 decibels, and even at top chat, it's only 40 decibels. Well, 35 decibels is the equivalent to whispering in a church or a library, so you really don't hear it. Noise, and there's a number of these quiet ones on the market now, but noise is not a problem.
Perfect. I mean, I suppose as well as location, you think about that as well, perhaps not perhaps putting it under your bedroom window or something like that.
Well, again, this one would be it's slightly higher than, where our windows are, but you wouldn't have a problem this one outside a bedroom window, because in the summertime it's not on when the windows are open for fresh air, and in the wintertime a double glazed window would easily keep the noise out.
Okay.
You need somewhere, there's a little pipe there. In the wintertime, because it's taking 10 centigrade out of the air temperature, when the air temperature is 1 or 2 centigrade, this big heat exchanger at the back, so air is sucked in through there, and the process of it's a bit like a refrigerator in reverse, that will freeze up, that will frost up, and then the system goes into reverse and warms that up, and then you get water flowing out. So you need somewhere for the water to flow out, and that's what that little pipe is there. It just does that all automatically on a cycle of probably every few hours. Insulation, you can see that the pipe work at the moment is well insulated, and that then runs through into my garage, which I'll just walk you through now, and show you what effectively is. Let me just open the garage doors. This unit on the wall is effectively the boiler. So this is the thing that replaced the my oil boiler, and I'll show you where that was originally. But you can get combined units. They're called mono something or other. Sorry, I've forgotten the name of it.
Monoblock. Is it monoblock?
Thank you very much. But in our case, it was better for us to have them separated. So the unit itself is just the other side of this wall. You can see the pipe work coming in here, and then it goes out over the top, along through. So you do need a space to locate that, or you say a monoblock. I'll continue to talk about the air source heat pump for a moment, then we'll take questions on that, and then I'll point out a couple of other things. It then flows into this cupboard, which was originally where the oil boiler was, and this is the design bit that's required from the heating engineer. I had probably 10 quotes, and the at least 5 of those said, "Oh, we have to replace all your radiators, and your pipe work has to be replaced, because although we have large pipes going up into the loft, you see the large pipes running out from the system into the loft. The pipes that then run down to my radiators are actually a micro bore." But at the time, I was going to be married for 24 years, and I wouldn't have seen my 25th wedding anniversary, because my wife said, "We're not changing pipe work, and we're not taking up radiators. I don't want the upheaval in the house." So the system had to be designed in order to meet that, and that's what this helps. This then is it's a buffer tank between the way the air source heat pump runs outside, and then everything to the right of this hasn't changed in my house, in my bungalow. We just have this large pump that then pumps the heated water, so the air source heat pump can run however it wants to, running through this buffer tank. And then when it gets to a certain temperature, this pump kicks in and starts then flowing the warmed water through my radiators around my house. And that would be my key difference, I suppose, from a retrofit compared to a new build. With a new build, you could put underfloor heating in, which would increase your efficiency even more, do away with radiators. You wouldn't need this buffer tank that the air source heat pump could then connect directly into your heating system, but we couldn't do that. We had to have to maintain the efficiency and not require the air source heat pump to run as it wants to. The buffer tank was put in place. Any questions on that?
We have a couple that have come in. What temperature does the radiator circuit operate at?
So the system was designed to run at a higher temperature. Can I come back onto my camera a second? How do I switch this around? There we go. Oh, there you go. You get to see me again. Sorry. It was probably originally designed to run at a higher temperature, something like 60 centigrade. That then impacts the efficiency. So over time, for the first year, we were controlling the system using a Nest, which is a smart controller. For the past year, we switched over, and the air source heat pump was then managing itself through what's called a heat curve, a weather compensation curve. And we've gradually reduced the temperature of the radiators. So before, it was almost operating like a boiler replacement. But now it operates more like an air source heat pump, in the fact that it more modulates. So if the external temperature is -2, then the boiler will be, the air source heat pump will be running at a warmer temperature. If it's 10 centigrade outside, it'll then be running at a lower temperature. So it'll run from somewhere between 35 centigrade and 55 centigrade now, depending on the external temperature.
And did you find that okay over the winter with the radiators?
Yes. So we had a couple of nights when it was -10, and everything's fine. In fact, I was going to get my wife to come on and stick her head on the video, but she wasn't keen. She thinks that the house is warmer and more stable now we have the air source heat pump than it was when we had the oil boiler, because whereas an oil boiler is modulating, over a range, that the air source heat pump is more stable and it keeps the house, the bungalow, at a more constant, even temperature.
Another question we've had, how big are the internal unit and buffer tanks for the air source heat pump?
So that's the 25-litre buffer tank. And what do you mean by the size of the unit? So that the
how many kilowatt hours is the heat pump?
So this is a large heat pump. So it's a 12 kilowatt heat pump with a 6 kilowatt booster, but we've never had to use the booster. Even down at -10, it was sufficient to keep running and to keep the house warm. Oh, you mean dimension? Somebody said dimensionally.
Yeah.
The unit, the external unit is, as I said, is below the planning requirement of 0.6 cubic meters. I think it comes in at about 0.57 or something like that. This unit itself is probably maybe a meter. It's just under a meter high.
Yeah, Richard just says he believes it's the same size as a wall-mounted boiler. Would that be about right?
Yeah, that sounds about right. Yes.
Yeah.
And
thanks,
the controls are all here, and that's probably the only downside of the Daikin, I would say, over some of the competition. The reason we went with Daikin was because they offer a 10-year fixed price service and maintenance contract, and nobody else did that. The downside is that they don't have there's not as much information about the efficiency, etc., and I have to go and get a reading off that chart and then calculate it myself. I'm happy with that. One of the other things I was going to just walk through would be I'll walk you through to where the hot water tank is, hot water cylinder. In an ideal, in a new build property, you'd want this hot water cylinder as close as you can to the air source heat pump, because then you get losses heat in the pipe, etc. We haven't got that. The other thing I just wanted to mention while I'm at this end of the house is, so here's our, no, it's not, because you can't see the picture. here's our consumer unit. So we had an extra trip switch added into there, 32 amp circuit for the air source heat pump, which is then linked through to another circuit in the garage. This one is for the solar panels, and I'll just talk a little bit about that. And then this little unit on the wall here that I'm just highlighting is called a Solic 200. That takes any spare electricity that we're generating, and I don't know, you can see there are 3 green lights on it at the moment. Any spare electricity we're generating, and it transfers it to the immersion heater for the hot water tank, and we get free hot water. It just heats it, but it does it dynamically. So if we switch the kettle on, or the washing machine comes on, or whatever, and needs electricity, it will switch off the heating, and then when the electricity is not being used by the kettle or whatever, it then takes the restarts heating the hot water. That saved that's why the air source heat pump isn't on at the moment, because we get more than enough hot water during the summer.
I had a few more questions for you that have come in just while you're there. So what's the square meter of your property roughly? Do you know the area?
So I said at the beginning, we're about 210 square meters, so it's quite a large bungalow.
And did you have to add any kind of insulation to improve the fabric before installing the heat pump to make the air source heat pump to make it more viable?
So we had we'd made improvements just over the life of the property, having been here for more than 20 years. So I don't know whether you noticed when I walked outside, but we have a lot of glass. It's supposed to look like a glass house, actually. So if this is that's an ordinary window pane, we've got 80 something of those around the house. So when we had the windows replaced, they're triple glazed. That was just going from double glazing to, they're originally wooden window frames, but if we'd have gone with double glazing to triple glazing, it was only about £3,000 different. So we made that decision to make that investment. Those are a centre U of 0.7. So again, it's about efficiency. We doubled the loft insulation from 150 mil to 300 mil for very economical and very easy investment. And then other things like, let me just show another example here, where we've got extractor fans, in the bathrooms and in here in the utility, that used to be just open fans. So if the wind blew, you get a cold draft blowing in. I got those replaced with these ones from Icon, which have an iris cover over them, which then means it stops the draft. So it's again just about removing drafts, etc.
Julian, while you were just there, Claudia said, what was the name of that third unit on the wall? I assume she means the one you were talking about, kettle.
So that's from a UK-based company called a Solic, SOLIC 200. There are a number of these, they're called electric diverters, available on the market. If you maybe it's best if I show, if you've got an electric vehicle, then you might buy a product from a company called My Energy, and they have a Zappi charger. I'll just show you an example here. So that's my electric vehicle charger. It's plugged in at the moment. They have a version of a Solic or a electric diverter, so you might want to get part of their their group, if you like. There's also one there's the ones from other companies. The reason I chose that one, this was 10 years ago, before we had the electric vehicle charger. It's just beautifully engineered. It just gets on with the job. Again, there's no data from it, but it had a 10-year warranty and made locally. But there are others on the market. Was there more questions on this space?
There was just one question about any idea what your SCOP is.
Oh yes, we'll come on and talk about that.
We're going
I'm
to
very
talk about
proud.
that. Okay.
Hold that question. So
There we
the one thing I did mention was, so the bad bit of design in our house, I just want to go and show you the hot water cylinder. In a new build, it'd be good to have it close to where your air source heat pump is. Ours isn't. So we're going to go for a walk now, just to show you the distance where the hot water cylinder is, which reduces the hot water efficiency. So here I am, and I'm going to go through the kitchen.
It's like being on that program Through the Keyhole, isn't it?
Through that. Let me just show you the dining room. So our sitting room and our dining room are double height. So the hot water pipes run. There's the utility. They go up into the ceiling here, through the kitchen ceiling, through that loft ceiling there, through an office ceiling here, and then we come to the cylinder here. I can now hear myself echoing in the background, so I won't shout so much. So this is the hot water cylinder. It's from a company called Mixergy. It's an intelligent hot water cylinder that sits, I can monitor it on the internet. This could heat in 3 ways. It can either be use gas or oil, or to heat the cylinder, but it has an immersion heater in it. This bit of well insulated covering here behind there is the heat exchanger for the air source heat pump heating the hot water cylinder. So it's an external unit. But the advantage of this cylinder is that it heats the water from the top of the tank, so you only need heat as much as you require. So if I just turn the light off, I think you'll see that we're at almost 100% now because of the free heating from the solar PV. But it works out how much hot water you require based on your usage. So it uses artificial intelligence to work out. So if you're, and they come in various sizes. This is I think it's 180 litre slim model, but they go all the way up to sort of 300 litre massive models for big houses. But I really recommend it. Again, it's a really good product. I had it at the same time as my air source heat pump, but you will have to have a new cylinder. Your existing cylinder in a retrofit won't be sufficient because it has to have large heat exchangers inside the tank. Right, I'm going to go
and
back
do you
to
have sufficient hot water? Is everything running fine with the hot water? Any problems?
Yes, we have sufficient hot water, and because of the way that heats from the top rather than having to heat from the bottom and the whole heat the whole thing, it recovers very quickly if you've used up all the hot water. Let me turn this off a second. I'm going to go back to my desk. One moment.
So keep the questions coming in for Julian as he walks back to his desk.
Hello.
You're back.
Yes, can you hear me?
Yes, we can.
Right. So somebody asked about the SCOP. That's the seasonal coefficient of performance. So we're at 3.72. So that's 372% efficient, and that's over 2 years. So for 1 unit of electricity coming in, we get 3.72 kilowatt hours of heat out. I think I mentioned at the beginning, we used to use about 5,500 kilowatt hours of electricity. I got that down to 4,000. Then when we had the solar panels fitted, we were down at about 2,200, 2,300, I think. That's gone up significantly to something like 9,000 kilowatt hours a year. And people might go, oh, it's a big number, and it is a big number. But that's all our energy needs, including we don't buy any petrol anymore because we've got EVs. So of that 9,000, about half of it, just under about 4,200, is associated with the air source heat pump. The rest is for cooking and lighting and other electrical needs. plus a big chunk of it is for the electric vehicles that we run. So you don't have to buy petrol or anything like that anymore. So that's why it's a big number, but it's lower than the total price we used to pay. Now, got any more questions? Sorry.
Yeah, one just came in. What kilowatt hours of generation do you have annually from the PV system?
I gave that number earlier, but we've forgotten. So I think we do about 3,600 kilowatt hours a year from the PV. It's quite, for its location where we are, as I said, rural Worcestershire, it's quite efficient, and we're south facing without any shade or anything like that. So
did you say that your running costs have gone down moving off oil then to the or would you say
it's about break even? The oil cost of oil, I haven't checked recently, but it, you know, with the terrible goings on in Ukraine, the cost of oil had gone up to over £1 a litre. So therefore, I was actually, even though electricity costs had also gone up, I was well under that. We used to use about 1,200, 1,300 litres a year, maybe 1,500. If I do the calculation now, we're using about that amount of electric for the same heating. As I said, my wife is more pleased with the heating now than we used to have with the oil boiler. I don't see it as a break-even point in that case. It's more a case of as a saving opportunity. If the house, I guess, was even more efficiently insulated, we might do. But I continue to try and drive the stop up the seasonal coefficient of performance.
Well, I think you're right. So quite often people assume perhaps that heat pumps are going to lower their running costs, when in fact not always the case. But it is obviously reducing your carbon emissions from burning fossil fuels, and that's where the savings come in terms of like the planet, rather than necessarily making reducing running costs, and especially with electricity being so high. But that's why you've got your PV. And that's really good that you can use the PV for it, perhaps in the summer. In the winter, do you find that it contributes much towards the running cost there of the heat pump?
No, we're heavily. It's a very skewed generation graph. You probably actually generate the most electricity when it's colder weather but really sunny. But it's actually the height of the sun and the length of the day has the most effect. So with the longest day a couple of days ago, and that will have generated the most because they had the most opportunity for sun and bright day. So I think yesterday I checked, we did about 18.5 kilowatt hours of electric for the whole day. Whereas in the winter, you might be lucky to get 100 watt hours on some very dark, dismal, wet days.
A few more questions have come in. Do you have individual room controls to help save energy usage for areas that are not?
No, I'm dead against them.
Are you?
The reason being, your house, your home is insulated on the outside, and the roof and the floors. So think of it as a box. If you divided up that box into the rooms, they're all cavity chiprock and painted walls, but there's no insulation between them. So if you switch off one room, pick a bedroom or a room you're not using much, the heating system, whatever it is, has actually got to work harder to keep that room warm. So it's a negative thing, I think. It's the control that all industry trying to sell you technology you don't need. You're better off just running it the whole house at a constant temperature. We run ours now. We start off at about 18 centigrade in the morning. This is in colder weather. We rise to about 19.5, 20 centigrade by about 7 o'clock, 7:30 when we're sat down in front of the telly, and then we step that down at about 10:30, 11 o'clock at night to 14 or 15 centigrade overnight, and then the cycle carries on again.
Is that just because they're the temperatures you want to run it at, or are they your maximum temperatures?
That's we're sufficiently warm. I must admit, in the wintertime, I'm not walking around in a short and t-shirt, shirt and t-shirt and shorts. I would have a jumper on, but the system was designed for different room temperatures and higher room temperatures. But we've helped. You know, we didn't need it that warm. Yes, whilst I am king of the gadgets, I don't think it's necessary to have these individual room controls. I think it's very little benefit, and it's just costing you money.
And you said you didn't change any of your radiators, is that right? You kept the radiators, so
Correct,
you gone for larger, because quite often people say you need to have a larger surface area, larger radiators. Edward's mentioned larger radiators would make a big difference, maybe getting down to 35 to 40 as a maximum flow. I know underfloor heating is much more efficient, but obviously retrofit is not possible always, is it, to pop that, you know, it's quite an undertaking to fit underfloor heating in rooms.
Yes, and as I said, my wife was dead against the idea of ripping up radiators. So I didn't catch the guy's name, but he's absolutely right. Yes, the way our house was originally designed, I think I showed you, like the dining room has double height, the sitting room is double height. So those already had quite large radiators. They were double skin radiators with two lots of zigzag radiators inside them. Fins, that's the word I was looking for. So double skin, double fin. The only thing we could do is what's called a K3, which would then have 3 radiators. We are wondering about whether we might swap one in a couple of the en-suites, but otherwise we haven't felt, even when it was down at -10 for those couple of nights in December last year, we haven't felt the property's cool. As with any heating system, it would have, whether it was our oil boiler and the air source heat pump, it was working hard when it was -10 outside. Yeah, it's been fine. It's worked out really well. One other thing I ought to mention is people should consider the electric company that they're taking their electricity from, and also the particular tariff. I'm on a dual tariff because of the electric cars. We on a cheap rate overnight and a higher rate during the day, which obviously has an impact on the air source heat pump. But it's, for me, my calculations say that's the best thing. I happen to be with Octopus, but there are others, because it's, I'm putting a big chunk of electric into the EVs, and it's more economic.
You mentioned the service plan earlier, the one you went with, and you said you've got a 10-year service plan. So for those who don't have an air source heat pump, we all know with gas boilers, it's an annual service. What's the deal with air source heat pumps? Like, is it an annual service? And, how much typically does a service cost? Do you know?
So, yes, you have to have an annual service. They have to come and check the running of the system. They'll clean it. They'll take the front off, and they'll take and do electrical checks on the and pressure checks, etc. I pay, and it's good value. I'm paying £264 a year fixed for 10 years, which includes an annual service and any warranty or labour. If there's ever a problem, they'll come out and fix it. And I wasn't aware of any other Samsung or now his brain dies as I can't remember any other big air source heat pump manufacturers, Mitsubishi, Ecodan, any of the others didn't seem to do this 10-year fixed amount. Now it's gone up since then, and there's a higher level of service available and one below mine. But I think it's really important. I think you've got to keep the thing maintained. And I've had no problems with Daikin. They've been really good at supporting. I've had 2 services and that's it. I ended up, my guy who installed it, company who installed it was called EcoBubble, and we're based out of Warminster, I think. And
how did you find them, Julian? What did you do some research into that to make sure?
Yes, in fact, I think I've talked about that on a previous one of these podcasts. But as I mentioned, it's really important to get a heating engineer, and rather than a plumber or a salesperson, because they're the ones who are going to come to your property and do a heat calculation. So that's a heat demand and a heat loss calculation per room, and then work out what size system you require, and then design it specifically for your property. Now, I did have this was during the COVID days, which was a bit of a problem, but I already had a view of, sorry, let's take a step back. When I first started inquiring, there was no information on the internet. There were a couple of videos by Robert Llewellyn from Fully Charged. He was come across them on the on YouTube. But whereas if you're buying a washing machine or a car or almost anything else, you can go to What Car or Which Magazine and get some more information and make a decision about whether you're going to spend £200 on a fridge freezer or £500 on a fridge freezer. There was nothing on to compare one air source heat pump to another. So all I did to start off with was ask dumb questions of people, either over the phone, via video or via email, and you gradually become a little bit more educated, and then you can ask more sensible questions. But I ended up getting about 5 quotes, and they offered, there's a company called Stiebel Eltron, who are described as the Rolls-Royce of air source heat pumps. There's another company that I got quotes from, another one from Daikin, one from LG, something from Samsung and Mitsubishi. I couldn't, the Stiebel Eltron system was going to be £2,000 more, and I couldn't understand the difference looking at the specification. It didn't seem any more reliable. They didn't offer this 10-year fixed price service contract, so I knocked them out. And I ended up going to, the choice was either going to be Daikin or Mitsubishi Ecodan. Mitsubishi are actually made in Scotland, so all the parts are going to be available. So I thought that was very positive. Their machine at the time was slightly noisier, and I really like the look of the Daikin machine. So that's through the conversations I was having, Martin, who's the owner or joint owner of EcoBubble, he came over to me, me talking to him as knowing what he was talking about, and been in the business a long time. So that's why I ended up going with them, and they did a fantastic job. They were here for 2.5 days, installing taking out the old oil boiler, putting in the new hot water cylinder, and then fitting the air source heat pump.
Amazing. I mean, it's really nice to hear like positive story of retrofit, because you know sometimes you do get bad press, but if people don't go to heat engineers and they just go to salespeople, then you know that's usually where the problems arise.
Yeah, the only thing I wanted to add was I think somebody had asked about, and in the introduction it talked about batteries. We don't have a separate battery system in the house at the moment, but I have about 100 kilowatt hours of batteries in my garage between 2 EVs. And the next big thing for me is vehicle to grid, or vehicle to home, it's called. And I would replace my Zappi charger. I think I showed you that sitting in the garage, with a different charger, and it becomes a bi-directional charger. So you charge it free from the solar panels or overnight on the low-cost electric, and then charge the EV, and then take the electricity out from the EV during the daytime to run the house. And thus these bi-directional vehicle to grid, vehicle to load chargers are available at the moment, but only for the Nissan Leaf, because it's the type of connector. They are being developed, but that'll be a future retrofit for me. So rather than spending 10 grand on a Tesla Powerwall or a Give Energy battery set, that's my future plan. Use the batteries that we've already got.
Sounds like a good plan. Any more questions? I think people have kind of said thanks for answering the questions. Richard's mentioned there's a lot more selection of high efficiency air source heat pumps now, some capable of 70 degrees hot water generation without any electrical backup. And then Edward sort of said all heat pumps now are very close in noise level, as the MCS requires a maximum level there that he's popped in the chat. I think we're almost bang on time anyway, because you need to finish, but Thank you, Julian, for really
You're welcome.
kind of showing us around and, you know, helping us all see it in reality rather than just talking about it. And it's really great to hear such a positive story for a retrofit.
I don't think I'll be Steven Spielberg in my movie career, but hopefully it wasn't too wobbly as I wandered around.
No, I think you did a great job. It was really great. So thanks everyone. The recording will be available as usual. Simon from Meshwork will sort all of that out. And any further questions, you know, you can always post them on Meshwork. Julian, you're quite
Oh, yes, please, any further questions, I'm happy to answer them through Mesh.
Yeah, definitely. And thanks so much for your time today. It's fantastic. Have a lovely weekend. Bye, everyone.
Thank you.
Thanks. Bye.